My name is Vijay Nair, and I'm here to give a quick demonstration of the funnel system. What is the funnel system? In short, it's a software system that runs in the cloud that's meant to, at low cost and high performance, serve flexible queries for real-time data. So who does that matter for? This is most important for businesses that are doing ride-hailing, micromobility, food delivery, or anything where there's a huge amount of data pouring in and there's constantly a need for large numbers of queries for that data that needs to be up to date to the second. So what is Funnel? So Funnel is composed of three software components that are deployed in the network. Your data pours in at very high rates. It could be from taxi drivers, it could be from food delivery people, and there's a system called the mouth, which is essentially built to receive all that data. The mouth is built in a load balanced manner that allows it to receive very large amounts of data, which is bundled together and distributed to other systems via a software component called the stem. Once this data is collected, it's distributed to these services called the spout, whose main purpose is to organize, index, and serve queries that you may have on your data. Your data can reflect anything you want, and it's defined in these files called schemas. The schemas are written in Apache Avro, which is an open source format, and then you can start uploading your data that is in accordance to that schema. You can then query that data in a syntax that may look familiar if you're familiar with things like SQL. And here's an example query. It's basically saying car type is economy type, and the coordinate is within 2 kilometers of this latitude and longitude coordinate. And of course, the system is secured properly so that other people and prying eyes can't see access to your data. In a nutshell, what it's doing is it's combining the benefits of a cache system, which gives you really high performance, and it's giving you the query flexibility of a relational database, but doing it very efficiently, which means at much lower costs compared to a traditional solution built using relational databases and cache systems. So that's enough general talk about the system. Let's actually look at a demo of what this system looks like in practice. Here we have a simple JavaScript service that is looking at data. Now the funnel system is what's in the backend. It's the one that's powering these network calls. It's not actually this JavaScript page. So here we have a query of data within Berlin, and we can actually see the data schema that we're using for this demonstration purposes. So this is equivalent to the kind of schema you would write in your own system. And in this case, there's not very many fields. There's this one field here called status, which can take two different values, either active or inactive. In fact, you can visually see them here. The active cars are the ones that are fully opaque, and the inactive cars that are the ones that are half opaque. They look gray in this picture. There's an ID field, which is a string, and this is what uniquely identifies a car. So whenever there's an update, as long as the ID is the same, it'll replace the previous data point. So if we look at this car, for example, there's myfleet-31. That's the ID of this particular car. We also have a field called age, and like I said before, it's a comparing field. So we can do greater and less than queries on this field. And then we have this field called coord, or coordinate, and it is indexed in a spatial manner, which allows us to search by latitude and longitude coordinates, which is exactly what we've done. If we look at the query we have in this particular case, we can say coordinate within 1.5 kilometers of this location, which was pulled from the map. You can actually see the coordinates being modified here on the left as I move the mouse around. Let's experiment a bit and see what we can see. Here we have just a square of data of cars, and we're only searching 1.5 kilometers away. Well, what if we increase that? What if we wanted to search for 10 kilometers away? Well, then we see we actually have an additional amount of data of cars that are out here, further out from where I'm located. Let's zoom in. We know we've got a lot of inactive cars that we don't necessarily want to have in our picture. So let's limit our filter result. I want to say within 1.5 kilometers of my coordinate, and I want the status to only be equal to active. In that case, all those gray cars are now gone, and I have now filtered my data to only include those. And you can also combine things in other ways as well. I could say I want this within this distance and the status is equal to active. And let's say I want to filter it further. I want to say and age is greater than 45. age is greater than 45. In this case, there's a lot fewer cars, and of course I'll get the reverse of the cars if I say age is less than 45. You can combine the data in other ways as well. So I can say I want the distance is within 1.5 kilometers of this location, and let's make it more interesting. Let's suppose if you're close, it doesn't matter if you're active or inactive, but if you're further away, you better be active. So in this case, within 1.5 kilometers, and I don't care about your status, so let's say, and I could say, or you're within a bigger radius, let's say 10 kilometers, but you have to be active in this case. So within 10 kilometers of, let's just use the same coordinate that we had before. And status is active. So here's our new query. It's broken up into pieces. You can be close within 1.5 kilometers. This will get active and inactive cars. Or you can be within 10 kilometers, but then you have to be active. So what we expect to see is a collection of gray and black cars here, but then if we zoom further out, we expect to see only the black cars. The names of my symbols are active in all caps and inactive. So here we have our gray cars over here and our black cars over here as we expected, and if we zoom out, we only have the black cars. Likewise, just for the sake of a simple query, I can say I only want the inactive cars that are far away, and you get the reverse. But the most interesting thing here is that all these cars, no matter how much data is actually present, the system runs very, very quickly. It's built for scale. It's built to handle the kinds of problems that your company may be facing. In fact, I think I have quite a bit more data located here in Kansas. And likewise, I can just search for the data and get it back in a blink of an eye. And here's that data over there. If you're interested in learning more about Funnel Labs and you think this system might be applicable to your business, go to funnellabs.io to learn more. Take care.